Hi everyone. In this video, we are going to revise the complete international math curriculum right from the topic 1 to topic 10. Obviously, you can see topic 2 is numbers. No, that's not the case. The first one is with respect to the calculator understanding. So here, after each topic, we are going to do some of the past paper questions as well, which will be somewhat like this. So as you can see, these are recent past papers from 22, 23, and so on. And I'll try to be as quick as possible so that we can cover all the syllabus. In case if you want to go in depth of any of the topic, definitely you can check out our website where I have some recordings of our classes. So make sure to check out our website even for the materials as well. So without wasting any time, let's start with the first topic. For this, we are going to refer to Oxford book and we'll just go through all the topic through the textbook so that we don't miss any of the concept or any of the topic. So let's start with this. I think the basic and all we can just skip, like rational, irrational number, the type of numbers and all. I think you might have an idea about it. These are all just addition, subtraction of numbers, BODMAS rule, this rule, that, PEDMAS, BODMAS, whatever it is. Okay, fractions, addition, subtraction. I hope you guys are comfortable with it. Just remember one thing, that whenever we do 5 by 6 divided by 1 by 2, so of course what we do is division is nothing but multiplication, so you just have to reciprocate the second term, so it's going to be like this, 2 1, and this is 3, so the answer is 5 by 3, which is quite simple. Even these topics are quite simple, so we'll just keep adding. Decimal number conversion to fractions and all, I think it is quite simple. So if I have 0.84 and if I want to convert that into fraction, it's going to be 84 by 100, and then after that all you have to do is you just have to simplify it, so it's divisible by 4, you can say, so it's going to be 21 by 25. That's going to be your answer. Recurring. Now see, I am not going to teach you how to solve it, but maybe I'm going to give you some tips which you can use it for your exams. So for example, so the shortcut would be for recurring numbers would be, so if I have 0.4 number recurring, so what I prefer is, that's see, 0.4, if I want to convert it in fraction, it's going to be 4 by 10, but when it comes to recurring, it's going to be 4 by, instead of 10, it's just going to be 4 by 9. If I have 0.47 recurring, of course you can imagine, because 0.47 would be in fraction, it's going to be 47 by 100, but for this thing it's going to be 47 by 99. Okay, so you can use shortcut to verify. You know that you have to multiply by 10, then subtract and all of those procedure, but at the end of the day you can check the answer through this method. Prime number, odd number, even numbers, all of these things are quite easy, so you can do it. Now if I want to categorize numbers, so numbers, like the real numbers, obviously the numbers are divided into real number and complex numbers or imaginary numbers, but the real numbers are divided into two categories. One is your rational numbers, which are in the form of p by q, and the other one is irrational number, which is like quite irrational, like root 3, root 7. Root 9 is not irrational because root 9 can be written as 3, so that's going to be a rational number. Now rational numbers definition is, it is in the form of p by q. Now you will say how 3 is in the form of p by q, because I can write 3 as 3 by 1 or 6 by 2. So these are all rational numbers. Now of course integers and your even odd numbers, those are just category through it. Just remember that fraction, decimal, percentage are not the type of numbers, they are just representation of the numbers. So obviously we are going to see it later. Remember that okay, I'll give you an idea. So fraction means 1 by 2, decimal means 0.5, while percentage is just way of representing the same thing with respect to 50 per century percent, so it's going to be 50%. All of these are all equal thing. Yes, now when it comes to rational number or irrational number, so here irrational number can be represented in the third form, which you can see here, root 5, root 27, root 3, whatever this thing. So here third is just a form in which we can write the numbers. So here first thing is simplification of surds. So if I have something like this, root 27, so what I can do, I can factorize this thing and I can write this thing as 3 into 9, or maybe I can write this thing as root 3 into 3 into 3. Now if I see a pair here, so I'll just put this 3 outside and it's going to be what? It's going to be 3 root 3. Other way, you can just find square root of 9, which is 3, and it's going to be 3 root 3. Multiplication and division of rational numbers is quite easy. So even if I have root 2 into root 3, I can just combine it and it's going to be root 2 into 3, which is nothing but root 6. But if I want to add root 2 plus root 3, That's not going to work, because consider that this is nothing but your x plus y, so you cannot add it. But if I want to multiply x multiplied by y, I can write this thing as x into y divided by x by y. Root 2 by root 3, I can write this thing as root 2 by root 3. Like root 2 by root 3, if I have, I can combine that and I can write this thing as root 2 by 3. Okay, then yeah, when it comes to addition, so for example, if I have something like this, root 2 plus root 8, if I want to add, so for that I can simplify this root 8. This root 2 cannot be simplified, but this can be written as root 4 into 2. Now square root of 4 is nothing but 2, so it's going to be root 2 plus 2 root 2, which is like x plus 2x, and that is nothing but 3x, so that's why it's going to be 3 root 2. So obviously there are multiple questions based on it. We can see all the questions maybe after, when we do the review set and all. So I'll just solve one of the questions. So if I have 2 minus root 3 whole square, so if I want to simplify, these are kind of questions which they ask. So if I have something like this, what I can do is, I can, obviously, a minus b whole square is a square minus 2ab plus b square. So it's going to be 2 square minus 2 times root 3 plus root 3 square, which is nothing but 4 minus 4 root 3 plus 3. So at the end, this is nothing but 7 minus 4 root 3. Without using calculator, simplify this thing, whatever it is. So let me consider just a random L. So here it's root 80 by root 45. So as I told you that you can combine the roots whenever it comes to division. So I can write this thing as 80 by 45. Now I can definitely simplify it. This is nothing but, it's divisible by 5. So this is 5 times 9, and this is 16. So as you can see, it's like root 16 by 9, which I can also separate. So it's going to be root 16 by root 9. Obviously, you don't have to take so many steps, and the answer is going to be 4 by 3. Then you have something called rationalize the denominator of these fractions. So rationalize means what? You don't have, you simplify in such a way, even if I consider, let's say, 8 by root 2, in such a way that there shouldn't be root in the denominator. So when it comes to something like this, I don't want root in the denominator. I didn't say anything about the numerator. So to remove the root in the denominator, I'll multiply the denominator by root 2. But obviously I cannot just multiply anything by root 2 in the denominator. So I'll have to multiply also by root 2. In short, I'm multiplying by 1. So this is nothing but 8 root 2 by 2, which eventually gives me 4 root 2. But now when it comes to something like this, if I have 4 by root 3 plus 1, and if I want to rationalize this thing, now see, maybe you can think of multiplying by root 3 plus 1 upon root 3 plus 1. But if I do that, this is nothing but in the denominator. See, I don't care about numerator. I only care about denominator. I don't want root in the denominator, in short. So here, if I multiply that way, it's going to be root 3 plus 1 whole square. And if I expand it, at the end of the day, it's going to be 4 plus 2 root 3. But once you simplify, so any which ways there is root in the denominator, so you cannot do it. So that's why you have to multiply by the conjugate of the denominator. If I do that, it's like the property, like factorization also, it's a part of it. So a plus b, a minus b is nothing but a square minus b square. So this is what we are using. So here, numerator 4 root 3 minus 1, okay, but denominator would be what? Root 3 square, which is 3 minus 1. So the overall answer would be 4 root 3 minus 1 upon 2. And if you simplify, it's going to be just 2 times root 3 minus 1. Of course, you can expand the bracket. It's going to be 2 root 3 minus 2. Now, this is what sequences are. Maybe we can keep it for later. Or okay, fine. So even there is something called sequences here. Okay, we'll follow the textbook. So now see. So generally sequences are of two types. One is arithmetic progression, one is geometric progression, and you have a lot of progression, a lot of sequences later on as well. So right now, whatever they are doing, we'll just look into it. So here we are talking about this nth term or arithmetic sequence, arithmetic progression, sequence, whatever. Now, this is a very simple game. So for example, if I have 4, 9, 14, 19, what could be the next term? Of course, as you can see, I'm adding 5, 5, 5 to the previous number. So definitely next number would be what? So I'm going to add 5 to it. It's going to be 24. Next number would be what? Again, I'm going to add 5 to it, 29. So as you can see, this is the first term. This is the second term. So I can write this thing as n. N stands for the which term it is. So first term is 4, second term is this, third term is this, fourth term is this, fifth term is this, sixth term is this, and so on. Okay, 6, 7, 8, 9 we can still figure out by adding 5 to it. But if I ask you 100th term, then how will you figure it out? So for that, obviously, we are not going to keep on adding 4 5 5 5 to it and then find out the 100th term, which will be too much of a task. So for that, we'll make a formula out of it, of this arithmetic progression. Of course, I'm not going to take in depth like how this formula is made. You can check out the videos for that. Now here there is a shortcut which I can tell you definitely. So if I want to find un or any nth term of arithmetic progression, this works for any arithmetic progression. So it's going to be what? So see, I am adding 5 to the previous number, right? So I'm adding 5 to the previous number. The shortcut would be what? So it's going to be plus 5 1 for sure. Now if there would have been a previous term, what it would have been? I can say it's going to be what? I will subtract 5 to it, so it's going to be minus 1. That's going to be the formula for un. Now if I want to find out the 100th term, so u100 would be what? So it's going to be minus 1 plus 5 times 100, which is nothing but 500 minus 1, which is 499. That's our answer. Works for negative numbers as well. So let me consider one of the sequence from here only. I think this one, 7 5 3 1 and so on. Obviously you can find the next term minus 1 minus 3 and so on. You are just subtracting 2 out of it. So un would be what? Un would be, I am subtracting minus 2 from it, right? So it has to be minus 2n. What would have been the previous term? If there would have been, it's going to be 9. So the answer is 9. Remember, in sequences, we'll come to that topic later on as well. But here 9 minus 2n, remember that if you want to verify for any of the sequences, just put n is equal to 1. If you want to really verify again, just put n is equal to 2. If I put n is equal to 1, I'm getting 7. Mostly I'm correct. If I put n is equal to 2, I'm getting 9 minus 4, which is 5. 100% I'm correct. So in some of the questions in past papers, I've seen that there is one sequence, second sequence, and there is the third sequence, which is quite weird. But remember that first sequence, second sequence, if you solve it, you add it, you take a difference out of it, so it might be connected with the third one. So make sure in paper you think about it properly. Some of the sequence can also be like this, n square plus 1. So they will directly give you the formula n square. Write down the fifth term. Just put n is equal to 5. You will get what? You will get 5 square plus 1, which is nothing but 26. 100 terms. So it's going to be 100 square plus 1, which is whatever, 10,000 plus 1, 10,001. So that way you will get the answer. Then we have something called approximation and estimation. Now here, obviously now if I have 8.57 and if I want to put it in two significant figures, remember these are three significant figures, three numbers like that. So here, if I want to convert that into two significant figures, so this is going to be what? This is going to be just 8.7 is there, which is more than 5, so it has to be 8.6. If it would have been 8.54, then it would have been what? It would have been 8.5 because 4 is lesser than 5. And yes, of course, for 5 also we are going to put as 8.57. So correct to one decimal place and this and that. Yeah, so here also if you talk about this in one decimal place, so you first convert it into two decimal, it's going to be 11.24. Then as you can see, for the first decimal it's going to be just 11.2 because 4 is just lesser than 5, that's why. So this is quite simple. Give an estimate. So in estimation you just have to like consider this way. Generally just have to write it like this: 82 maybe then into root 900 upon 2.824. so maybe you can write this thing as 3 or something and you can just estimate the answer. Yeah, this is an important one, which is standard form. I was just thinking about, is there anything with respect to estimation? Okay, so what about the standard form? So here standard form means what? So if I have certain numbers like this 500, or in fact just think about it in physics, chemistry and all of those things, atomic weight and all, so you have this 2 into 10 to the power of minus 27 or some certain figures. Even if I talk about the distance from here and there, see, writing this, it's a task, right? So obviously what we will do, we will use a standard form for it. So what exactly it means? There has to be just units placed. That's the whole point. Meaning if I have 9,000, so the standard form will be what? It's going to be 9 into 10 to the power of 3. If I have 0.0084, so this is going to be what? So first of all, it has to be in units place. So I can write the same number as 84 by 1 with 8.4 by 1 with, see, I'm shifting 1, 2, 3 steps on the right hand side. So it's going to be 1, 2 and 3. So this is nothing but your 8.4 into 10 to the power of minus 3, because the denominator is 10 to the power of 3 indices, it's going to be 10 to the power of minus 3. Did I miss indices? One second, I think it's later on, I guess. That's okay, whenever it will come we'll see. Yeah, okay. Now when it comes to certain question like this, okay, so for example, yeah, maybe we can look at this one of the past paper question itself, so we'll get an idea. See, look at this question. These are the recent past paper questions. So here, when it comes to something like this, you can use calculator also, but this should be without calculator. So 10 to the power of 1 into 7 into 10 to the power of minus 3. Give your answer in standard form. So see, what we'll do, first of all, we will multiply 7 with 1.5, right? So that's going to be how much? One second, that's going to be 10.5 into 10 to the power of, if I multiply this 10 to the power of 1 with 10 to the power of minus 3, I hope you are clear with the indices as well, because a to the power of m into a to the power of n is nothing but a to the power of m plus n. So here 10 to the power of 1 into 10 to the power of minus 3 would be 1 plus minus 3, which is 10 to the power of minus 2. Now the thing is, this is not in standard form. So now what I do for this thing, pay attention carefully, this is my way. So here see, definitely I'm going to write this as 1.05 into 10 to the power of something, because it has to be with respect to units place. Now for that, all you have to do is, see, you have to make a balance out of it. So 10.5, I'm converting it into 1.05. Matlab, what I'm doing, I'm just, decreasing it. 10.5 it was, so now I'm making it as 1.05. So simultaneously on the right hand side, I'll have to increase it. So this is going to be what, 10 to the power of minus 2 it is. So if I want to increase it, so I'm going to add 1 to it, so it's going to be 10 to the power of minus 1. Let me take one more example. Okay. So by chance, if you come across something like this, 0.025 into 10 to the power of 7. Now if I want to convert that into standard form, so as you can see, obviously I'll have to write it as 2.5 into 10 to the power of something. Now remember one thing, here this value I have increased it, so definitely this value I have to decrease it. By what? So I can shift the decimal 2 places, so that's why I'll decrease it by 2, so it's going to be 10 to the power of 5. I hope you got it. One more question they have given, let's see this one. Root 75 minus root 48 plus root 12. So here, as I told you, you cannot add these directly. You will have to simplify for it. Sorry, 48 plus root 12. So for that, all you have to do is, as you can see, you can factorize this 75. Worst case, factorize with respect to prime numbers. Maybe you can write this thing as, see here, so I can see it's just 3 into 25. Okay. This is, I'm not able to figure it out, ki 24 hai, ki what hai, whatever. So at least I can figure out 4. So it's going to be 4 into 12 plus root 12, so I know it's going to be 4 into 3, that way. So here you can simplify. Square root of 25 is nothing but 5, so 5 root 3. And see, mostly the whole, whenever they ask you to simplify, the whole question will be in terms of root 3. So here again, see, I can further factorize this 12 as well. So it can be written as 4 into 4 into 3 plus this is nothing but square root of 4 is 2, so 2 root 3. Now this complete thing would be what? It's going to be 5 root 3 minus, there are 2 4s in it, so it's going to be 4 root 3 and then plus 2 root 3. Overall this would be what? It's like 5x minus 4x plus 2x, so x plus 2x, which is 3x, so it's going to be 3 root 3. I hope you understood. Like basically I'm just considering root 3 as x to simplify. Okay, now let's move further. Conversion, little bit of conversion is also there, so I'll just take this question. The speed of light is 300,000 kilometer per second. Express that in centimeter per second. Acha, this is okay. So here kilometer you are going to convert it into centimeter. So okay, conversion whatever it is. So 300,000 kilometer per second. See, per second we are not modifying, right? So we are only modifying kilometer. We are converting that into meters and that meters into second. So for that, for kilometer to meter, obviously we are going to multiply by 1000. Then we are done with meters. Now meter to centimeters, so we are going to multiply by 100, because 100 centimeter is 1 meter. So it's like 3 into, there are 5 zeros here, 3 zeros here and 2 zeros here. So 5 plus 3 plus 2, which is 10. So it's going to be 10 to the power of 10 centimeter per second. Hmm. These are just various questions. Maybe we can see through the past papers. Let's see. Standard form and all, we have already seen it. Anyways. Then we have something called ratio, proportion, percentage, fraction, all of these things. Just remember one thing, that if I divide something into half, like if I divide this circle into half, okay, and this is A, I'm like consider it as beta. So if half A person is getting, half B person is getting, so the ratio is not half or 1:2 or something like that. It is 1:1, equal proportion. So that is nothing but your ratio. Here one person is getting half, the other person is getting half, so it's like half is to half, which is nothing but 2:2, which is 1:1. Like I'm just saying that, even 100 is to 100 is also 1:1. So the ratio is that. Proportion could be anything. In fact, the other way around, sorry, proportion could be anything, ratio has to be the same, 1:1, that way. Okay, so very simple. So if I want to divide $40, they have given in the ratio 3:5. So remember that, see, here 3 parts one person is getting, 5 part other person is getting. But out of how many parts? So we have divided it into 3:5. So total part, there are total 8 parts. So first one will get 3/8 of 40, while the other one will get 5/8 of 40. Now, of course, you can solve it. This is 15 and this is 25. Obviously you can subtract also. If it is 2:3:3, so as you can see, there will be 8 parts. So first one will get 2/8 of 184, the other one will get 3/8 of 184, and another one will also get 3/8 of 184. Even 4, 5 ratios, whatever. So that is all possible. That like with respect to the word problems, I'll do it later on when it comes to questions. So that time I'll give you the idea how to deal with it. Okay, these are all proportion and all. Just remember one thing, is when it comes to these kind of questions, like 3 men can build a wall in 10 hours, how many men would be required to need a wall in 7.5 hours? So obviously we need to increase the number of men, so just don't do it that way. So it's an inverse relation, or it's an inverse proportion, or the direct proportion. So that way it is. Take it, chalo, I'll give you an idea. So for example, if I talk about something like this, so we will always use something called comparing quantities. We are going to use this for percentage as well. So it's a very important thing, so pay attention carefully. Now here, we are going to compare, like, see, we are trying to make these things into comparison, meaning, so let me consider one of the questions, very easy question. So if 100 people drinks 300 liters of water, let's say, so 150 people will drink how many liters of water? Okay, so what we are comparing, we are comparing people with water. Generally that money and all is easier to understand, but I'm just giving an example. So here, if you know the given condition like this, and if you want to find out this condition, so generally what I prefer, so what we need to find, that I write it in the first line, and the second line I write whatever the given condition is. So here 100 people can drink 300 liter of water, so 150 is just x, we need to figure it out, correct? So what we are going to do, we are just going to use this cross thing, or you can just write this is equal to this. So x would be what? X would be just, you multiply 300 that side, so it's going to be just 300 into 150 by 100. So this is direct relation, because if I increase the number of people, obviously the intake, water intake will also increase, so that's going to be 450. But when it comes to something like this, 3 men can complete the work in 10 hours. How many men will be needed to build the wall in 7.5 hours? So here I'm comparing men with their work. What I know is that they complete, sorry, one second, 3 men can complete the work in 10 hours. We need to find what? We need to find how many men are required to complete it in 7.5 hours. Now see, this is when it comes to direct, when we increase the quantity, we use this is equal to this, right? But when it, so in a way we are just crossing it, like 100 times x is equal to 300 times 150. But when it comes to inverse proportion, matlab ki, or maybe that if I increase the number of men, the working hours will be lesser. So here what I'll do, here I'll multiply x with 7.5 and 3 with 10, and I will solve it. So basically 7.5x is equal to 3 times 10. So x would be what? It's going to be 30 by 7.5. So it's going to be 4. That's going to be the answer. But of course, see, in exam, if you're getting the number of people in decimal and all, so 0.5 and 0.7 people does not exist. So maybe you must have made some mistake. To make sure you keep that in mind. Conversion and all, ठीक है यार, मतलब like simply same thing. Again, see, convert 22.5 to dinar. Okay, this one. So here, take it, forget this way, whatever they have done. So here, what we know, where is it? Dinar, this one. We know, we are comparing dollars with dinars. Okay. So here, what we know $1 is 0.29. We need to figure out $22.5, which is x dinar. So here, direct, of course, if I increase the number of dollars, the dinar will also increase. So x is going to be what? X is just going to be, again, that cross multiplication thing, or just this equal to this. So x would be what? X is going to be 0.29 into 22.5. Whatever the answer, 6.53. They got. So again, comparing quantities. This will be helpful in percentage as well. So I think that would be the next topic. So you'll get an idea about it. Map scale. Okay. So now what about this map scale? So if I want to convert, let's take an example. Next is percentage. Okay. So just map scale, a very simple thing. One second. Okay. Normal, so it's fine. So if the map scale is 1:100. Okay. If the scaling is 1:100. So it's like 1 centimeter is equivalent on map to 100 centimeter. That's the thing. I'm talking about this one. Okay. What does area 1 centimeter square on the map represent? Okay. Now see here. If I talk about this 1 centimeter square, so it's like this much on map. It's like 1 centimeter by 1 centimeter. With respect to the map, 1 centimeter is actually 100 centimeter on map. So this is like meter into kilometer, and all of these things also works. So it's like 1 centimeter is actually 100 there, and this 1 centimeter is 100 there. So it's like 100 into 100. So for me, I just do it like this. See, 1 centimeter into centimeter is, it's like 1 centimeter into 1 centimeter. That is 1 centimeter square. So this would be equivalent to 100 whatever, like on the map, 100 units or 100 centimeter into 100 centimeter, which is going to be 10 to the power of 4 centimeter square. I think this one would be a better example. So see, convergence, basically convergence and maps are just almost same. It's just mapping, you have 5, 200, 2000, whatever the conversion is. So see, if I want to convert 1 meter to how many centimeters? So remember one thing, 1 meter is, obviously 1 meter is a huge quantity, and if I want to convert that into centimeter, so it's going to be a huge number centimeters, so it's going to be 100 centimeter. If I want to convert 1 meter square into centimeter square, so see, it's like 1 meter into 1 meter, so it's like meter into meter. So for converting that meter into 100, like this meter into 100, so I'll multiply by 100. This meter into 100, again I'll multiply by 100, so I'll get what? I'll get 10 to the power of 4. Volume, if I talk about 1 meter cube, if I want to convert that into centimeter cube, so it's like 1 meter into meter into meter. So it's like I'm converting each meter to centimeter, so 100 into 100 into 100, which is 10 to the power of 6 centimeter cube. Obviously this you can use for kilometers and this or whatever. Now if I want to convert 1 centimeter cube into meter cube, so here, or let's say 10 centimeter, random value I'll consider, 10 centimeter cube into how many meter cube. So again it's like 10 centimeter into centimeter into centimeter, right? So here what I'll do, this centimeter if I want to convert, so this 10 as it is, this centimeter or this centimeter I'll convert it into meter, so I'll have to divide by 100 into 1 by 100 into 1 by 100, whatever the calculation is. I think it is, this got cancelled and you'll get what, you'll get 10 to the power of minus 5 meter cube. That's the answer. Same goes with meter square and all. So mapping also you can relate to this way. Just remember that whenever you map it, so you should know कि whenever you are multiplying by a huge number or dividing by a huge number, like which side of the map you are looking at, like this small one or the huge one. Okay, percentage. So see, percentage is nothing but per century. So if I have, let's say 3 by 4, and if I want to convert that into percentage, so it's like how much it is with respect to per century. See, I'm not going to go with respect to the theory about where it is useful and all. For that again you'll have to go through the whole lecture and all. We are going to keep it very quick. So 3 by 4, if I want to convert that into percentage, I'll have to multiply this by 25 because I want per century, right? And because just like in that rationalizing thing, we multiply numerator and denominator by a certain number, so here also we'll multiply this by 25 to get 100. But definitely you cannot just multiply randomly, so I'll have to multiply numerator also by 25 to get 75, and that is nothing but 75 per century or 75%. Change to percentage. So in short, now instead of doing all of those things, what you can do, I want 100 in the denominator, right? So what I'll do, I'll just multiply by 100 and divide by 100 and simplify. Somewhere down the line you will get the answer. So here this 100 I want to keep it, so it's like this would be 4, this would be 25, so I'll get 75%. So in short, whenever you want to convert fractions into percentage, simply just multiply by 100 and you will get the answer. So for example, if I have 0.31, in fact decimal also, decimal is 0.31 by 1, right? So it's like I want 100 in the denominator, so I multiply numerator and denominator by 100 to get 31%. This is 72%. This is 33.33%. See, it's easy if you can convert fraction into decimal. Decimal to percentage is quite easy, that's why. You just have to shift the numbers, that's why. I think these are quite easy. Yeah, now this is something interesting. Just a random question. See, in Thailand, the population of a town is 48,700 men and 1,600 women. Huh? Okay, weird. Okay. And 16. What percentage of the total population are men? So here all you have to do is 48,700 divided by total population would be 48,700 plus 1,600. And since I want percentage, this is in fraction, or I can convert that into decimal and then I'll multiply by 100. That's the thing. Percentage increase and decrease. So see, remember one thing. So here also we are going to use that comparison thing. See, rate of change of percentage is quite simple. So when a tax is added to the cost of a camera, its price increases from 165 to 184.8. What is the rate at which tax is charged? So how much money has been added to this 165? So it's like 9 plus 10, so 19.8. Over what? Over the final cost, right? So 19.8 upon, one second. No, so it has to be on this cost, what do you call, $165, and that again you will multiply by 100, you will get the answer. So whatever the percentage it would be. Now see, these are quite interesting questions. So when it comes to something like this, a book is sold for 5.4, so selling price, so we are comparing again percentage with pricing. So here see, a book is sold for 5.40 at a profit of 8% on the cost price. What was the cost price? So cost price we don't know. Okay, so now see, here cost price is basically at what price we have purchased it and at what profit we are selling is this selling price. So see, 8% profit matlab, see, remember that this has to be on that cost price which is 100%. So cost price is 100% while the selling price is 108. What we know that selling price is 108, which is 5.4. So what would be the cost price? Just x, again same thing. X would be what? X would be 5.4 into 100 by 108. Whatever the answer would be. ठीक है, in case if you want 540 by 108. 5. Anyways, okay, for this let me take one of the examples from the past paper. Yeah, we can do, yeah, this one. See, nahi, ye to, it's gonna be a little bit tricky. See, look at this question. This looks like a question. So Urs, whatever, Uras buys some clothes and sale. He buys a jacket for $22. The original price of the jacket was 25. Calculate the percentage reduction in the price of the, basically discount. So see, again we are going to compare the price with percentage. So he buys a jacket for $22. The original price of the jacket was 25. Now see, original price as in that's going to be the 100% price. So here what we know, 100%, sorry, this percent is here. So 100% price was 25. He buys it for 22. And we need to find how much is the discount on it. So here, see, we will get the actual amount, that at what percentage it's going to be. So here it's going to be what? So x would be what? X would be just 22 times 100 by 25. Again, same thing. This is equal to this. So this is 1, this is 4. So we get it as 88. Right? So 88% is this value. Like 88% is this. So actual deduction of this price is how much? It is going to be 12%. I hope you understand. Now second part of this question. So he buys a shirt for 13.5. This is the price after a reduction of 10% of the original price. Calculate the original price. So again, price percent. We are going to compare the quantities. So here when it comes to buys a shirt for 13.5. So the price, what we know, 13.5. This is the price after a reduction of 10% of the original price, which is 90%. So we need to find original, which is 100, and that's going to be x. So that's it. So x is going to be what? X is going to be 100 times 13.5 by 90. 0, 0 cancel. This must be divisible by 9. So it's going to be 10 times 13.5. It is 1.5. Yeah, this is nothing but 15. So this was the original price, which is $15, and it kind of makes sense. Okay. Like, see, these questions, so you can try it from the, these are all worksheets which are on the website, so obviously you can try it from there. Then we have something called simple interest, and there is, I think, compound interest later on. Yeah. So simple interest is quite literally simple, I would say. That was a bad one, but still. Here, see, if I simple interest, I'll compare it with compound interest to have an idea. So let's say if I invest $1,000 here, $1,000 here. So every year the bank gives you certain amount. So simple interest is what? So if the rate of interest is 10%, so here what would be the interest he is gonna get, which is gonna be, interest is gonna be PRT, which is a formula, and it kind of makes sense also. Think about it. It's like, when I increase something by 10%, so it's gonna be 110 by 100 into that thing. Okay, yeah, this is something also which I wanted to tell you with respect to percentage. So see, if I want to increase 70 by 10%, if I want to increase 70 by 10%, so what I have to do, so it's like 70 and I'm increasing it by 10%, so I'll have to multiply by 110 and divide by 100. Similarly, like obviously 10% increase matlab like that way. In fact, you can use that comparing thing also to figure it out, but I think it is easier to understand. So when I talk about decrease, so 70 you multiply by, you decrease by 10%, so it's going to be 90 by 100 that way. Whatever the value is. I know that, finding 10% of it and adding is easier. Finding 10% of it and subtracting it easier. But this could be the universal method. Like even here also, you can understand it. It will take little bit more calculation, but at least with respect to the questions, it's going to be easier. Anyways, coming back to this thing. So obviously, you can understand that 10% rate of interest, matlab 100 rupees, $100, whatever, the bank is giving every year. So interest formula is PRT by 100, where actually principal amount is this 1000, rate of interest is 10, and time for how many years? So for 1 year it's going to be just 1. So R by 100. So you are just finding 10% of that 1000, which is 100, and you are just adding to it. So here interest according to formula 1000 into 10 into whatever time 1 upon 100, which is 100. Of course you can cancel this, cancel this, cancel this, you will get 100. So first year after 1 year it's going to be 100 rupees interest and 1000 principal amount whichever we have invested, so it's going to be 1000 plus 100. Second year it's going to be 1000 plus 2 times of 100. Third year it's going to be 1000 plus 3 times of 100, and so on. When it comes to compound interest on the other hand, so here if I talk about this compound interest, it's maybe if you understand, it is related to geometric progression. So what exactly I mean by that? So see, so after 5 years or something down the line, for this one it's going to be what? It's going to be 1000 plus 5 times of 100, which is 1500. Now what about compound interest? So here, see, in this formula generally people get confused. See, understand, this is interest what we get it. In compound interest, for the formula we get the amount, we get it after the years. Here we have to add interest to the principal amount to get the final amount. Here we get the amount directly. So now what exactly it means? So see, if I invest 1000 and after 1 year we are just going to increase by 10%. So it's like, see, 1000 into 110 by 100, which is just 1100. Now there is an increase of 10% here, so it's going to be 1100 into 110 by 100. So these gets cancelled and you will get what? 1 second, what happened? ठीक है. This another got cancelled. Okay, 1331 it should be. Once again I missed it. Yeah, 1331. Sorry, 1210. My bad. I was just looking for the third year, that's why. So anyways, it's going to be 1210, right? Now see, compared to this, after 2 years this would have been 1200. I'm getting 10 more years. So compound interest is always better if the rate of interest is same. Then for the next year it's going to be 1210 times 110 by 100, which is like 1331. Yeah, so this is what you get. So here I would have got 1300 here, but if you compare here I'm getting extra 31. Now if you see the pattern, comparing it with the principal amount, so this is 110 by 100 to the power of 1. This was already 1000 into 110 by 100, but this time it's going to be 1000 into 110 by 100 to the power of 2. This time it's going to be 1000 into 110 by 100 to the power of 3, and so on. So we carry out this thing. So after, let's say, 10 years, how much would be the amount? So it's going to be 1000 into 110 by 100, because that is the percentage it is multiplying, to the power of 10. That is what the value will look like. Whatever, you can use calculator. Generally there is a formula also, but I don't prefer formula if you understand this thing, because it's just quite a logic that you are just adding 10% to the amount. So multiple times it's just getting multiplied again and again and again and again. Because of this formula you can understand the depreciation as well. So let's say if you buy a car of $10,000, okay, and the depreciation is 15%, like every year 15% gets depreciated. So see, I'll give you a best example. You must have seen that somewhere there's a discount of 50% plus 50% off, that is 100% off. No, it's not like that. It's like 1000 rupees, there's a product of 1000 rupee, so it's like 50% reduction, which is 500. So it's kind of repeated percentage as well. minus 50%, then 50% on this thing, again 50% if I subtract from this thing, I'll get 250. Now see, for this also it is quite easier to understand if you concentrate on 50% directly, like we are doing that 50% again and again repeatedly. So it's like 50 by 100. If I want to do it once, it's going to be 1. But if I do it 50%, then again 50%, it's going to be to the power of 2. So as you can see, it's like 1000 into 1 by 4, which is 250. So here, if I talk about this car example, $10,000, and there is a depreciation of 15%. So here, the amount would be what of that car? So it's going to be 10,000 into, let's say 15% depreciation. Matlab like here it's going to be 85. If it would have been compound interest of 15, like interest is 15%, so I would have taken 115. Now after 1 year it's going to be 1, after 2 years it's going to be 2, after 3 it's going to be this, after 5 years it's going to be this value. Whatever, you can use calculator for this. So look, there is this one question we can think about. See, again past paper, the population of a species of a bird is estimated to be decreasing by 4% per year. 4% per year it is decreasing. Find the population at the end of 2019. So they are asking before it, like before this thing. So here, as you can see, like we are comparing population with percentage, right? So percentage and population, again comparing quantities. So here, estimated to be decreasing by 4% per year. At the end of 2020, the population was 4.32 million. So what do we know? 4.32 million was the population when it has already been decreased by 4%. So that is nothing but 96. Because certain population, if it is 100% previously and I decrease by 4%, I'll get 96. This is what we need to figure it out. So here x is going to be what? X is going to be 100 times 4.32 by 96. Which if you calculate, it's going to be 4.5. And it kind of makes sense then. Okay, calculate an estimate for the population at the end of 2025. Now see, at the end of 2025, matlab after 5 years. So in 2020, at the end of 2020, the population is 4.32. So it's going to be 4.32 million. And every year it is decreasing by 4%. So it's going to be 96 by 100. And at the end of 2025, so after 5 years, so that's going to be the answer for the B part. Find the year in which the population is first expected to be below 2 million. So see, 4.32, and we are going to continue that thing, 0.96 to the power of 5, 96 by 100. Sorry, to the power of n. After how many years we need to figure it out. So these are the number of years. This would be 2 million. That's it. So here you will get what? You will get 0.96 to the power of n is 2 by 4.32. Now this is something related to logs. So what you can do, so maybe during the logs we can see it, but as of now I'll just tell you there is this rule called tick mark rule. So if I have a to the power of b is equal to c, and if I want to convert that into logs, so b is going to be what? B is going to be log c to the base a. So here again we are going to use tick mark rule. You will get n is equal to log of 2 by 4.32 to the base 0.96. Again another shortcut. Whatever the answer is, you can use calculator for that. Then we have something called speed, distance and time. So obviously, you know, speed is what? Distance upon time, or distance is speed into time. So that formula you just have to use it. So which one should we take? One of the questions. So obviously with respect to a question it would be easier. One second. So in a similar fashion, I think there is this one question which we can think about it. Like converting it into meters per second and kilometers per hour, so kind of conversion. So see, a car travels at 300 meters in 20 seconds. So 300 meters in 20 seconds. So if you want, this is nothing but 300 by 20, which is 30 by 2, which is 15 meter per second. That's what the thing is, like every second it is traveling 15 meters. Find the average speed of the car in meters per second. We already found out that is 15 meter per second. But for kilometer per hour, see, it's like 15 meter by second, and we need to convert that into kilometer by hour. Correct? So meter to kilometer would be how much? So for that, we are converting meter to kilometer. So of course, meter is a huge, like meter is a very small value, but it will have huge numbers. So if I want to convert it into kilometers, so I'll have to divide, because meter to kilometer, so I'll have to divide by 1000. On the other hand, if I want to convert seconds into hours, so for that also, second is a small quantity, hour is a huge quantity, so there will be many seconds which will convert it into hour. So for that also, second to hour, I'll have to divide by something. So see, second to, like, maybe you can use reverse also, hour to minute is 60, minute to second is 60 again, so it's like 60 into 60, but it's like 1 by 60 into 60, so it's going to be into 60 into 60. Cancel out these things, this thing, whatever, we will get the answer then. In fact, we can solve it. This is 2, this is 3, this is 2 again, this is 3, so 18 times 50, 18 times 3, which is 54 kilometer per hour. Kind of makes sense also. Obviously don't get these answers of a car as 540 kilometer per hour or 5.4. In case if I find some difficult questions on speed, distance, time, that also we will solve later. But yeah, overall, you just speed is equal to distance upon time, and then you figure it out. Generally, I've seen some of the questions where people find it difficult, that when it comes to journey kind of question, like, traveling from this point to this point and then coming back. So remember one thing, there you make equations with respect to the situation. So the complete journey, let's say there is this particle which is a bird or something like that, it's traveling from this position to this position, and then it is coming back like this. So understand, what you know the complete journey time. Okay, so this would be the complete journey time. Okay, so we are comparing the total time with respect to t1 plus t2. Speed is equal to distance upon time. Speed is equal to distance upon time. So time is distance upon speed. So this distance, let's say it's 40 kilometers. So we know this is constant and this is also 40 kilometer constant. So it's going to be 40 by time, whatever they have considered, or maybe you must have got, it took 5 seconds more than the previous one or whatever. So overall this journey time, speed is x, so x plus t2 would be 40 by, and it took 5 meter per hour more, so x plus 5, that would be the total time, and it took 3 hours for that journey. So that way you can figure it out. I hope you got it. Like time 1 took 40 minutes. For this time 1, the distance was 40 kilometer. For the time 2, the distance was 40 kilometer again, but during the time 1, the speed was x, time 2 x plus 5. So this is all you have in numbers. Like we have discussed a lot: percentage, ratio, proportion, estimates, standard form. So now the next topic would be algebra, which will be the part 2 of this video.